Assalamualaikum and hi everyone. Welcome to our video presentation. We are pleased to present our topic today, which is transition method in medicine on how metals help diagnose and treat disease. Before we begin, let us introduce ourselves. My name is Siti Nur Arbaya and I will be presenting together with my members. First, we have Cik Muhammad Syahid Amir who will be covering the application in medicine. Second, Nur Zuliana will be covering the characteristic of transition metals. Next, we have Muhammad Amar who will discuss uniqueness of transition metals. Lastly, we have Siti Norazwani Aina who will explain the uses of transition metals in daily life. We hope this presentation will provide a better understanding of transition method in medicine. Without further ado, let's begin our presentation. Before we begin, let's look at the objective of our presentation. The objective of transition method in medicine are to explain the application of transition method in the diagnosis of disease. Next, to identify the unique characteristic of transition metals that make them useful in medicine. Next, to explain how the chemical properties of transition metals such as variable oxidation state, complex formation, and catalytic activity make them useful in medicine. And the last one is to understand how transition metals function in biological processes. What are transition metals? Transition metals are a group of elements located in the D block of the periodic table and known for their unique biological and chemical properties such as variable oxidation state, ability to form complexes, different coordination geometries, and redox activities. These metals commonly exhibit variable oxidation state and have partially filled d orbitals, which allow them to form a wide variety of compounds. Transition metals play a crucial role in many industrial, biomedical science, and technological applications. In medicine, transition metal complexes are widely used for disease diagnosis and treatment. For example, platinum-based drugs such as cisplatin, carboplatin, and oxaliplatin are commonly used in cancer therapy by damaging cancer cells. However, due to their side effect, researchers have developed other metal complexes such as manganese, iron, nickel, copper, zinc, and cobalt complexes, which have shown strong potential in destroying cancer cells, including cells that are resistant to cisplatin. Besides cancer treatment, transition metal complexes also show potential in treating microbial infections and neurological disorders by reducing oxidative stress, controlling metal balance in the body, and targeting specific disease pathways.
For this part, I will explain the characteristics of transition metals that make them important in medicine. First, transition metals have variable oxidation states. This means they can exist in different oxidation states, allowing them to take part in oxidation reduction or redox reactions. These reactions are essential for many biological processes and medical treatments. Second, they can form stable complex ions. Transition metals easily bond with ligands to form coordination complexes. This property is important in developing metal-based drugs and diagnostic agents such as platinum complexes used in chemotherapy. Third, some transition metals have magnetic properties. For example, gadolinium is used as a contrast agent in MRI scans because it helps produce clearer images of organs and tissues, making disease diagnosis more accurate. Fourth, transition metals have catalytic activity. They act as catalysts in many enzymes, speeding up important biochemical reactions. This property is also applied in biosensors and other chemical diagnostic technologies. Fifth, they have electron transfer ability. They can easily gain and lose electrons, which is important for respiration and energy production. For example, iron in cytochromes helps transfer electrons in cells. Finally, some transition metals have radioactive isotopes. For example, technetium-99m is widely used in nuclear medicine to diagnose diseases by producing detailed images of organs.
Now, I will explain one example that shows the uniqueness of transition metals in medicine, which is diatomic iron nanozyme with liposogenous-like or LOX-like activity. A nanozyme is a nanomaterial that mimics the function of a natural enzyme. In this case, the nanozyme contains two iron atoms working together to perform reactions similar to the lipoxygenase enzyme. The first important point is that the diatomic iron sites can damage the viral envelope. Many viruses, such as influenza and coronaviruses, are surrounded by a lipid membrane called the viral envelope. The iron nanozyme catalyzes lipid peroxidation, which is the oxidation of lipids in this membrane. Once the membrane is damaged, the virus loses its structure and becomes inactive. Because this mechanism targets the lipids envelope, instead of a specific viral protein, it can work against a wide range of envelope viruses. This is why it is described as having a non-specific virucidal effect. Another unique feature is the FeO-Fe motif. The special electronic structure of this iron-oxygen-ion arrangement allows its d orbital to interact efficiently with the lipid molecules. This interaction lowers the activation energy needed for lipid oxidation, making the reaction occur more easily and much faster. Overall, this example demonstrates why transition metals are so valuable in medicine. Their unique electronic properties and catalytic abilities allows them to drive chemical reaction efficiently, making them useful for developing new antiviral therapies.
Next slides, we have uses in daily life. First of all, we have a gadolinium for diagnose of diseases. For diagnose, we have MRI scans. MRI scan can improve the image quality, helping doctor to detect tumor, brain disorder and other abnormality more clearly. That's why gadolinium we're using in medicine. Next, we have a kisspelatin. Kisspelatin we're using to treatment of diseases. Based on the kisspelatin is platinum, and then we're using treatment is chemotherapy to treat a cancer such as testicular, ovarian, and lung cancer. And then kisspelatin works by damage the DNA of a cancer cell, preventing them from growing and dividing. And the last one, we have titanium. Titanium we're using to medical device and implants. The commonly we're using in artificial joints, little implants, and bone plates. We're using this because of the metals are very strong, lightweight, and human can using the daily life. And then the implants helps to restore movement and improve patient to have a quality of life.
We move on the application of transition metal in medicine. Radium can be used as a source of potential burn replacement materials, which is act as an raw material for calcium phosphate in bioceramics, or even act as absorbent for eliminating contaminants in aqueous solution at a reduced cost. Whereas iron, zinc and pyrolysis waste can be used as an effective catalyst support in trans-esterification of cleaning and discharging vegetable oils. Transition metals are vital in modern medicine with their unique ability to interact with biological systems. Unlike any organic drugs, they provide a versatile chemical toolkit to drive innovation in precision medicine and to improve patient outcomes. Thank you.